Good day, everyone. We are working out January 2021, paper 2, CSEC Mathematics. We are number 8 in section 2. We have a straight line graph, x equals 5 minus 3y, intersecting the x-axis at P and the y-axis at Q. We must determine the coordinates of P and Q. So at P, which is the x-axis, y is equal to 0. So we then substitute y is equal to 0 into this equation. So we have x is equal to 5 subtract 3 times 0, right, which is 5 subtract 0 because 3 times 0 is 0, which is 5. So coordinates of P would be x equal 5, comma, y is equal to 0. At Q, which is the y-axis, x is equal to 0. So we substitute 0 into the equation, x equals 5 subtract 3y. So we have 0 is equal to 5 subtract 3y. We solve the equation for y, so we subtract 5 from both sides. And we then divide both sides by -3. So -5 divided by -3 is positive 5 over 3. Coordinates of Q, x equals 0, y is equal to 5 over 3. Calculate the length of PQ given the answer to 2 decimal places. So let's use the formula for the length of a line segment, x minus x1 squared, the square root of x minus x1 squared plus y minus y1 squared. Let us call the coordinates of P 5, 0. Let us call that x and y. X equals 0, y equals 0. And let us call the coordinates of Q 0 and 5 over 3. Let's call that x1 and y1. So let's substitute these values into the formula. So now we have the length PQ being equal to the square root of x1, x minus x1, sorry. So x, sorry, that's one correction. All right, x will be equal to 5, and x1 will be equal to 0. So we have 5 minus 0 squared plus y minus y1, so 0 minus 5 over 3 all squared, which is the square root of 5 minus 0 is 5 squared plus -5 over 3 squared. So that's equal to square root of 5, 5 is 25 plus -5 over 3 times -5 over 3, that's 25 over 9. Remember, a negative times a negative number gives a positive. This is the square root of 25 plus 9 into 25 is 9 2s are 18, remainder 7 over 9. This is the square root of 27 and 7 over 9. I will use our calculators to find the square root of 27 and 7 over 9. Getting 5.27 as our answer. Correct 2 decimal places. So 5.27 units would be the length of PQ, okay? Line segment PQ. Okay, let's move on. R is the midpoint of PQ, determine the coordinates of R. So we have P being 5, 0. We have Q being 0 and 5 over 3. And we want to get the midpoint. So the midpoint R would have coordinates. All right, x plus x1 over 2, comma, y plus y1 over 2. All right, so 5 would be x and 0 would be x1, 0 would be y, and 5 over 3 would be y1. So let's substitute these values. So we have 5 plus 0 over 2, comma, 0 plus 5 over 3 over 2. Okay, so 5 plus 0 over 2 is 5 over 2. And then we have 5 over 3 divided by 2. Okay, so on the side here, 5 over 3 divided by 2 is the same as 5 over 3 divided by 2 over 1, which is 5 over 3 times 1 over 2. We have to invert the second fraction, which would be 5 times 1 is 5, 3 2s are 6. So we end up getting 5 over 2, comma, 5 over 6. 5 over 2 and 5 over 6. Right, as the coordinates of R, right? Okay, the midpoint of PQ. So the functions f and g are given. The graphs of f of x and g of x meet at the points m and n. Determine the coordinates of points m and n. So when they meet each other, they become equal to each other. At that point, f of x is equal to g of x. All right, so 5 minus x, right, which is this, will be equal to x squared minus 2x minus 1. All right, so what we do is we subtract 5 and we add x to both sides. Negative 2x plus 1x is negative 1x. Negative 1 minus 5 is minus 6. All right, so we have x squared plus 3x. We are factorizing. Now we are attempting to factorize. All right, minus 2x minus 6. Sorry, let's just change around these signs. Let's just change around these signs. All right. So we are going to use minus 3x plus 2x, okay? Because minus 3 plus 2 or negative 3 plus 2 will give negative 1. And negative 3 times positive 2 gives negative 6. All right, so these are the two numbers that we replace the middle term with, negative 3x plus 2x. Now we attempt to factorize. So we have x can go into x minus 3. And then we have plus 2 could go into 2x. 2 into 6 is 3. All right, so we have 0 is equal to x minus 3 times x plus 2. So we put x minus 3 equal to 0 as one possible case. And we add 3 to both sides, so x equal 3. We also put x plus 2 equal to 0. And we subtract 2 from both sides. So we get 0 minus 2, which is negative 2. So when x is equal to 3, we substitute x equal 3, all right, into this equation. So when x equal 3, when x is equal to 3, let's use f of x. F of 3 is equal to 5 minus x, which is 5 minus 3, which is 2. And when x is equal to negative 2, f of negative 2 is equal to 5 minus x again, which is 5 subtract negative 2, which is 5 plus 2, because a minus negative gives a plus, and that's 7. So the points m and n, all right, m could be x equal 3, y is equal to 2, and n could be x equal negative 2, y is equal to 7. Okay, so these are the 2 points of intersection between these two graphs, f of x and g of x. All right, so 3, 2, and negative 2, 7. All right, let's move on. Part C, Monty is cycling 12 meters per second. After 4.5 seconds, he starts to decelerate. And after a further 2.5 seconds, he stops. The speed time graph is shown below. So we have our speed time graph, and we are asked to calculate the constant deceleration. So the deceleration takes place at 4.5 seconds. It starts at 4.5 and it ends at 7. So the change in speed divided by time. All right, so change in speed divided by change in time. All right, so the speed went from 12 to 0. So the deceleration is 12 meters per second. And the change in time would be 7 take away 4.5. 7 take away 4.5, which is 2.5 seconds. So you divide by 2.5, speed divided by time. At 4.8. All right, meters per second squared. 4.8 meters per second squared. All right, that's our deceleration. Monty's average speed over the second 7 seconds. So average speed is equal to total distance traveled divided by total time taken. Now, to get the total distance traveled, you have to find the area under the graph. This is a trapezium. Okay, this is the shape of a trapezium, and there's a formula for finding the total distance or the total area of a trapezium. And we use a half a plus b times h. H represents height. We can say a is this distance, right, from 0 to 4.5. So a is equal to 4.5, right? This distance here. While b, right, is from 0 to 7, right? Okay, so we have a and b, and we have height here being 12, right? This distance height is our height. Height of the trapezium, which is 12. All right, so we substitute these values. A is equal to 4.5, b is equal to 7, and height is equal to 12. And we work this out. Then 0.5. All right. So this is 1/2 times 11.5 times 12. Right? A half times 12 is 6, so it will end up being 11.5 multiplied by 6. And that gives 69. So we have 69 meters. Let's make sure we are working on meters. Yes, we are working on meters. So we have the total distance traveled as 69 meters. We have the total time taken as 7 seconds, as given in the question. So average speed is equal to total distance 69 divided by total time taken, which is 7. So we divide this. All right, so 9 7 is 63. Remainder 6. All right, which could be expressed as, in a decimal form, we can say 9.8 9.86 meters per second to 2 decimal places, right? So this would be the average speed for Monty. Okay, and that's the end of number 8. Thanks for watching. Do have a good day.